Okay. Because every once in a while we have some videos that we watch, and so that has to be presented differently, and then it doesn't like it. And so, all right, Algebra 2. Let's go to our grade screen as usual. I like to click on the little icon there. We can see last week we had solving equations algebraically and graphically. Those were linear equations, right? That's what we did last. So this week we're looking at solving systems of non-linear equations and graphing systems of nonlinear equations. So, all right, just making sure I'm in the right place. I just feel kind of lost today. Graphing systems, yes, I know exactly what we're doing. This assignment is just like the 5 questions that we have. This one's going to take a little bit more work. This is not a little quiz with questions and multiple choice. This one's going to take a little work. And so do not neglect that. I have had people in the past get to the end of the semester and never turn that in because it required work. And those are the students that generally were having trouble even passing my class because they just didn't turn things in. So don't be one of those students. All right, let's look at 1.03, 1.04, solving systems of nonlinear equations. Spoiler alert, they work a lot like linear equations. They're just differently shaped. There's a few differences. Okay, the space probe Deep Impact was launched January 12, 2005, which is before many of you were born, most all of you. Let me look. Yeah, that's before all of you were born. So Deep Impact, the mission of this probe that we sent into space was to fly as close as possible to this comet called 9P Temple, 9P/Temple, and investigate the interior composition of the comet. You know, for some reason scientifically, we like to know what comets are made of. You know, somehow that helps us. So they want to see what's this comet made of. Is what kind of rock, or is it what kind of stone, or I mean, different metals, and what's in this comet. So did NASA's rocket scientists just pick a spot in the sky and say, just launch the probe up there and eventually that comet will come by? No, it doesn't work that way. It takes a lot of planning, a lot of algebra, a lot of systems of equations, because they have to figure out at what trajectory is this comet traveling? What is the path that the comet's traveling? And it's not linear because it's affected by gravity and the sun, and it's usually in orbit a lot of times, and these comets coming through. So they have to figure out what is the path of this comet. And they have to figure it out in 3 dimensions, right? We only deal with a graph in 2 dimensions. They're having to figure 3 dimensions. Then they have to figure, okay, if it's going along this, then what path will our probe launch on? So they launch that, it goes on this path, and they have to time it. How long will it take till it gets to this point? How long will the comet take to get to this point? When do we need to launch it exactly so it's in the exact right place where the comet is, where they're together? That's the solution to a systems of equation, right? When they're in the same place, that's the solution. So that's what they're trying to do, is launch this and get to the same place. But wait, comets don't fly in straight lines, they curve. That's right. So systems of equations we looked at were linear, but they don't have to be. And we can still solve them by elimination or substitution. Now, doing this, I'm going to switch over right now. I'm going to switch over to this. And let's talk about some of how this works. Okay, let's look at, we're just going to jump outside the lesson and do some work on our own here. Let's do 2 equations. One is y equals negative 2x. Okay, that's still linear, right? That's a line. Has a slope of negative 2, y-intercept of 0. It's just a line. But the equation we're going to solve with this is y equals x squared. Oh, we already got something different. We got a parabola minus 8x plus 12. Okay, we want to solve this systems of equations. We have 2 equations, one linear, one quadratic. Now, there is a shortcut we can use when we deal with these type of problems. So the first thing we want to do is simplify this first. So we're going to do this with substitution, because we have this lovely y equals equation right there. And there's a y right here that I can substitute it into. So if I want to use substitution, so let me write this over here. Substitution. Okay, we're going to solve this by substitution. So we're going to take this top equation right here and substitute it in for this y. So if y equals negative 2x, then this is negative 2x. Instead of y equals, it's negative 2x equals, because that's the same thing. And it equals 2x squared minus 8x plus 12. And I'm going to solve this for x, right? Well, when we solve a quadratic equation for x, we have to set it equal to 0. So we need to move this over to the other side. So we've got 0 left on this side, nothing. X squared, we added 2x and we had a negative 8x. So now we have a negative 6x plus 12. All right, now if you think back to solving quadratic equations, there were multiple ways to do that, right? Multiple ways to do that. I'll stop that real quick. We could factor, maybe, right? Maybe it's x minus 1 times x plus 3 or something like that, right? 2 factors equals 0. If it didn't factor, there was the completing the square, which was a bit more work, but it works. Sometimes you deal with fractions and get funny answers with that. I'm not going to go over completing the square in class because we're not going to use it right now. But if you want to a refresher on completing the square, come see me Friday. Friday is an A day, by the way. So we'll have class on Friday if you want to be here, or if your grade's below 70 and need to be here, because some of you haven't turned in last week's assignment, so your grade has dropped. So we can complete the square Friday if you want to know that, but I'm not going to cover it in class. The other thing you can do in solving quadratics is the quadratic formula. I have a video I need to post about that as well. The quadratic formula. So I'm going to start out with just writing the quadratic formula over here. I don't know if I'm going to use it yet or not. But if you remember the quadratic formula, it's x equals negative b plus or minus the square root of b squared minus 4 times a times c, and everything is over 2 times a. That look familiar? That was the quadratic formula. So the quadratic formula we can use for any quadratic equation. So I could solve this with that, but I may not need to. And remember, this only works when we have a quadratic in standard form like this is, which is ax squared plus b x plus c equals 0. We have to have our formula, our equation in that form in order to solve. So I'm going to underline that. So there we go, box that out. Okay, so if we have a quadratic that's in this form, ax squared plus bx plus c equals 0, we can use the quadratic formula. And it's not that difficult because when we look at it, the a just comes from the a in the equation right there. The b there's 2 b's. Oh, there's 2 a's too. I didn't mark the other a. There's another a right there. So we just use the a wherever it calls for an a. We use this b wherever it calls for a b. I guess I should make that a little bit more blue. And then we have the c that's only used once in the equation. The c goes right there. So we substitute in and then simplify that, and that'll tell us what x equals. Now, for systems of equations, I want to focus on just part of the quadratic formula. B squared minus 4 times a times c. This has a name. This, I didn't know if I left enough room. This is the discriminant. Ooh, I just barely left enough room. That's the discriminant. That's what this is called. And that is just this part of the quadratic formula, right? That is known as the discriminant. And we can use that to tell us if we need to keep working through this problem on systems of equations. I have these two equations, right? We have these two equations that we're using. This is what we're trying to figure out. These two equations, what's the solution? Let me take this, since I have it in this form, and find out what the discriminant is. So b squared. Our b is negative 6. So I'm going to say negative 6 squared. Now I got to put the negative in the parentheses because that's what b is. I'm squaring all of b, and b is a negative 6. Minus 4 times, what's a? Oh, there is no coefficient, so it's a 1. A is 1. And c is the constant, 12. Okay, negative 6 squared. So negative 6 times negative 6 is 36. Minus 4 times 1 is 4. And 4 times 12 is 48. The discriminant equal 36 minus 48, negative 12. So the solution to this is no real solutions. You're like, what? You already know that, Mr. Brock? You haven't even, how did you get that already? The discriminant is a negative. If negative, it only has imaginary solutions. Only imaginary solutions if it's negative. What do you mean imaginary solutions? Well, I'm saying if we use the quadratic formula to solve this, to figure out what x equals, x is going to be, it's going to say x equals 3 halves plus the square root of 3 over 2i. Remember, if you have an I, that's imaginary. So this is a complex number. This has got a real part and an imaginary part. This is not a real number. This is an imaginary number. And this will have, oh, this actually have plus or minus. It's going to have two answers. Square root of 3 over 2 plus the square, plus or minus the square root of 3 over 2i. Imaginary solutions, which means if we graph this, we won't see the solutions because we don't have an imaginary graph paper. We have real graphs. No real solutions. So that tells me right away I don't have to continue working this problem. And you're like, okay, let's prove that. We're going to go over to Desmos. We said, what are we talking about? No real solution. Negative 2x. Okay, there's the line. That's the first equation. The second equation, x squared, so it's a quadratic, minus 8x plus 12. Oh, look at our graph. They don't touch. We have a parabola, we have a line, they never touch each other. Zoom out, you see they get farther and farther away from each other. The closest they ever get is right down here. These graphs do not touch. There is no solution. No real solution. There's imaginary solutions, but we don't have an imaginary graph. We only have a real graph. I'm like, well, that's pretty cool. That discriminant. The discriminant will also tell you a few other things. And let me see. Is it on the first page? It may be the next page. Oh, it's right here, the discriminant. If we click on the discriminant, here's a little thing that's great to have in your notes. Because if you'd have known that about the discriminant, it saves you a lot of work. Here's a little graph, little table. Okay, using the standard form of the trinomial, this quadratic equation, using the b squared minus 4ac, which is called the discriminant. If the discriminant is negative, that's where I had down here, I had a negative discriminant. That means there's two complex solutions. And if you remember, complex means there's an imaginary. Complex has a real part and imaginary part. That means no real solution. So if you're making notes of this, where it says two complex solutions, I would write no real solutions, because that's what that means. No real solutions when it's negative. Here's the other possibilities. Maybe you calculate b squared minus 4ac and it ends up 0. If the discriminant's 0, there's one solution. One solution, and it's going to be a real number. It may be 2/3. It might be 6, but it's just going to be one real number. It's not going to be imaginary. What if it's a positive perfect square? Now, you have to think about what does that mean, a positive perfect square? Well, a perfect square is, well, what's 2 squared? That's 4. 4 is a positive perfect square. What's 4 squared? That's 16. That's a positive perfect square. 25, that's 5 times 5. 25 is a positive perfect square. So if it's any of those positive perfect square numbers, then you're going to have 2 solutions, and they're going to be rational, which means they're going to be, you could write them with a fraction or a number, maybe an integer. Maybe the solutions are 3/2 and 6, or -2 and 5. You know, if it's a positive integer that's not a perfect square, but it's a positive integer, maybe it's 7. Page 1, Lauren. I'll show you where it's at in just a second again. It's got 2 irrational solutions, and I'll show you a second. Right here on page 1, we're on page 1, right underneath the essential questions, you'll see discriminant right here in a different color. And if you click on that, it'll pop open that window. That's where I found that. Right here, it's underlined here on my screen. It's in green on my screen. It may be a different color depending on your theme that you've chosen, but discriminant. So that helps a lot. And what does it mean by 2 irrational solutions? Okay, well, let's have a quick refresher on rational and irrational numbers. So let's say a rational solution. That means it's something you can write as a fraction. A rational solution could be 2, it could be 3/2, it could be -11, it could be -5/7. Those are all rational numbers. What's an irrational number? An irrational number is still, it's not imaginary, it's a real number, but it could be 3 square roots of 5. It could be the square root of 7. It could be 2 plus the square root of 2. Any of those, anything that has like a square root in it like that, those are irrational. Irrational. But they're real numbers. The square root of 7 is a real number. It's just not nice and clean like 2, or 3/2 is even a nice number compared to the square root of 7, because it's a decimal that does not repeat. This is a decimal like 1.5, but it terminates. It doesn't keep going forever. This keeps going forever. So this is rational, this is irrational, just to know the difference. So when you see the discriminant can have rational or irrational solutions, 1 rational, 2 rational, or 2 irrational. But if it's negative, there are no real solutions. So I can stop right there. And we saw why there was no solutions, because they don't touch. There's nowhere they have in common. So, all right. So yes, with the quadratics, we may have to factor them. We may have to complete the square. We may use the quadratic formula. This just goes over, if you need a refresher, I'm not going to go over all this in class, but if you need a refresher on how to factor by grouping, this gives you the steps. All the steps in factoring. Factor by grouping, or just factoring it without grouping, solutions. And here's a review on substitution and elimination that we did last week using linear equations. So if you need a review of that, I'll leave that. You can review it, but that's just 2 linear equations they're doing there, substitution and elimination. But we're going to use substitution or elimination this week as well. So if we have like an equation like this, y equals x squared minus 5x plus 1, and x plus y equals -2. Well, this is a quadratic equation because it has an x squared on it. The second equation is linear because it only has an x, not an x squared, not an x to the third, not an x to the seventh. It's just an x. So how would we solve this using substitution? Well, when we do this on paper, you always have the solutions you can look at on the computer if you want to watch this little video, but we're going to do it ourselves. So we can walk through the steps. You can put in your notes. Let me get it written down, and then I will switch screens. X plus y equals -2. Okay. That looks right. So we can solve this, and it wanted to solve it. How did it want to solve it there? Substitution method. We can do substitution or elimination. So they want to do substitution. Perfect. We can do that. So this says, oh, well, it's already kind of set up for substitution because we know what y equals. That's what y equals. Y equals that. So there's a y. This y could equal that. So let's do that. X plus, and instead of y, I'm going to put this. X squared minus 5x plus 1. X plus y equals -2. Okay. Not bad so far. Let's simplify this because we got some like terms. We only got one x squared, so it's out front. But we got an x and a -5x. So we have -4x plus 1 equals -2. Got to set it equal to 0 to solve quadratic equations. So add 2 to both sides. X squared minus 4x plus 3 equals 0. Okay, perfect. Perfect. So now we can do anything. We can do quadratic formula. We can do factoring and do factoring by grouping. We can do completing the square. But this one looks like a nice, easy one to factor. Because remember, we have to have, I kind of like this method sometimes. Up here, top and bottom, what would multiply together to be 3? Well, there's only two options. 1 times 3 or -1 times -3. Right? Either one of those would give me 3. I also need to add them together for the middle term. Well, 1 plus 3 is 3. 1 plus -1 times plus -3 is -4. So I want this. Oh, this would be 4. I'm sorry. If I added those together, it'd be 4. If I multiply them together, it's 3. So I need to use the negative. So -1 and -3. Excuse me. I'm using my little x wrong. Haven't used it this year. I want to add together to be -4. I want to multiply together to be 3. So -1 and -3 satisfy that. All that to say, I haven't taught factoring in a while. Just kidding. This factors to x minus 1, x minus 3 equals 0. If you remember your quadratic factoring, like I said, we could just punch this into the quadratic formula, and it would give us those two x's as well. So that means x minus 1 equals 0, and x minus 3 equals 0. Because the only way this equals 0 is that means there has to be a 0. Something has to be 0 if you multiply it times something else. So if this is 0, x equals 1. If this equals 0, then x has to equal 3. So there are the two x's. So there's two solutions to this systems of equation. We have the x's. So it's 1 something and 3 something. Let's find out what the something is. We can choose either equation. Let's do one of each. Let's tell you what. Let's take the 1 and put it in the bottom one. So if x equals 1, x equals 1, so that's 1 plus y equals -2. So I just substituted the 1 in for the x because that's what it equals. 1 plus y equals -2. Subtract 1. Y equals -3. So when the x is 1, the y is -3. There's one of our answers. One of our answers. Let's find the other one. I'm going to find the other one using the other equation. You can use either equation. I could have used this one on both of them, but I'm just for fun. Okay, y equals, the x is 3. So this is going to be a 3 squared minus 5 times 3 plus 1. See, wherever there was an x, I've substituted 3 because I know x equals 3. So y equals 3 squared is 9. 5 times 3, so minus 15 plus 1. So y equals 9 plus 1 is 10 minus 15 minus 5. That's the two solutions. We did that by substitution. We could have done it by elimination. Let's look at it graphing just so we know why those are solutions. Let's get rid of these two equations. So our first equation is y equals x squared minus 5x plus 1. So there's our first equation. The graph, the parabola. And the other one was x plus y equals 2. Okay, what was our two solutions? 1 -3 and 3 -5. We got something totally different here. What did we do different? Did I type in the equations correctly? Oh, x plus y equals -2. I missed the negative. That changes everything. There's 1 -3. There's 3 -5. That's the two solutions we come up with. 1 -3, 3 -5. So if I graph it correctly, that's a -2. Then we see those solutions right there on the screen. 1 -3. Oh, I'm going to clean this up. I like it to go by ones and don't give me all them little lines. So there, now it goes by ones. But yeah, there's our two solutions. So we proved it algebraically by substituting, and graphically we see it by charting it on Desmos. And wherever they touch each other, that is the solutions. So some of y'all struggled with that on last week's assignment. I saw, we'll talk about this just for a moment. I was looking at last week's assignment. Some of y'all did really well on the first lesson, and then on the one where you saw it graphically, you bombed or had a lot more trouble than you did the first time. It's like, oh, that's like, because generally graphing is the easier one. I just put it on Desmos and say, oh, look, there's the answers. I can't make any math mistakes unless I type it in wrong and put 2 instead of -2, right? But if you type in the equations correctly, you know those are the right equations. All you have to do is look at the screen when you graph systems of equations and just find, okay, that's where they touch. Or if they don't touch, you know, there's no solutions, right? Or with lines, remember last week, we could have the exact same line on top of each other, the same line, which means there's infinite solutions because every single point on that line is an answer because both of them have those exact same points. So that was it. We either had infinite many solutions or no solutions because they were parallel and never touched, or you had solutions wherever they touch. That's a solution. With nonlinear, we can have more than one solution. Look, we have 2 solutions here. So interesting. Okay. Substitution method. They do a little video. Let's just fast forward to the end. Oh, they're not quite done there. Okay, there it is. 1 -3 and 3 -5. That's the same answer as we got. If you need to review that and want to go back and see them do the same thing in a video, there it is right there in your curriculum. So there's a link here if you want to see how to do that with elimination. Here's the steps to eliminate. But either way, you can do substitution or eliminate, whatever you feel most comfortable with. After you get used to this, you may feel more comfortable with graphing. But remember, graphing may be limited where there's a solution that's not an integer. Like if you got a solution that's 4.318 you probably need to do it algebraically to find out exactly what that number is because that's going to be rounded. Okay, here's the problem that I already worked first. X squared minus 8x plus 12 and -2x. That was the first one I did where we looked at the discriminant and we found out we didn't have to work the problem. They're solving it for the first variable. The discriminant is a negative integer. That means it's going to be 2 complex numbers which means the solution is no real solutions, because complex numbers mean it's imaginary. Okay, an imaginary part. So that was one where we used the discriminant for that. I probably should have tested the discriminant. Here, let's do that real quick. When I got it down to this equation right here, where it equals 0, I should have tested the discriminant. So let's highlight that, and let's see. The discriminant should have been a positive perfect square, right? So -4, let's check this discriminant when we got right here, the b squared minus 4ac. B squared, -4 squared minus 4 times A is 1, C is 3. So -4 squared is 16 minus 4 times 1 times 3. 4 times 3 is 12. So the discriminant's 4. That's a positive perfect square, right? Because if we take the square root, it's plus or minus 2. Since that's a square, that tells us that we would have 2 answers that are nice rational numbers, which we did. We had a 1 and a 3 as the 2 x's that we got out of that. So checking the discriminant knows, okay, we should proceed and we should get some nice answers, because this was a positive perfect square. We've already run out of paper, and we're barely off page 1 of our lesson here, first lesson. Okay, and here's the whole thing done in elimination. So you could have done elimination the same thing. So that's not a big deal. Okay, here's another one. They solve it both ways, substitution, elimination, with 2, count them 2, parabolas. So this looks like it'd be worthy to work on paper. Okay, what do you like on this? Would you like to do it by elimination or by substitution? I'll let you. We're not going to do it by graphing, because that's actually the next lesson. All right, so whoever gets the first in the chat gets to pick elimination or substitute. Daniel's already on it. He said let's substitute. He's already quick. Substitution or elimination. Okay, so that's really easy. If it's elimination, if we did elimination, we would just multiply the top or bottom by a -1. And so we'd have it like a negative y, right? And a negative x squared and a positive, so then we just add them together and the y's would go away. And the x squareds in this case would go away, which leaves us with just an x. But substitution, we can do it like this. So let's substitute the first one into the second one. We can go either direction. It doesn't matter, because it's going to look exactly the same. So here's what y equals. Y equals all of that. And here's y. So let's take all of that and substitute it in. X squared minus 9x plus 18. Okay, that's y. That's y. We just substituted in for y. What's it equal? Y equals x squared plus 2x minus 4. Okay, after we substituted in for y, we've got this. Now we need to get everything on one side. So subtract x squared. What do you know? It goes away on both sides, because x squared minus x squared is gone. So we have -9x plus 18 equals 2x minus 4. Subtract 2x from both sides. -11x plus 18 equals -4. Notice we're not going to have to check a discriminant, because we don't have a quadratic equation anymore. It's gone. It's not a quadratic equation. It's just linear. Let's move the 18 over, because we're just solving for x. -11x equals -22. Divide by -11. X equals 2. Look at that. One solution. Just one solution. We had all of this going on with 2 parabolas, got all this quadratic stuff going on. One solution. So what is that solution? It's 2 something. 2. We need to find out what the y is. So we'll take this 2 and let's just put it in the bottom equation for make it easy. There's what x equals. 2 squared plus 2. Oh, there's another x, so that needs to be substituted in. minus 4. So y equals 4 plus 2 times 2, that's 2 squared also, plus 4 minus 4. So 4 minus 4, that's the answer, 2, 4. We just simply substituted one in to where now they're equal to each other. We moved everything to one side, move the x's to one side, move everything one x to the other side, ended up with x equals 2. So let's graph these and see if we're right. Great way to double check our work. Let's just graph it. It was x squared minus 9x plus 18. That was the first parabola. Second one is y equals x squared plus 2x and minus 4. See what's going on? That's why there's only one solution. There's only one point where they cross each other. And it is at 2, 4 that we calculated. That was the point we came up with, 2, 4. And then when we graphed it, that proved it. Got the same answer when we solved it graphically. 2, 4. So very nice. All right. See how this is working? So here's the same thing. If you want to go through and see it works by elimination, you can go through this and it has all the work going through elimination. Exact same problem we just looked at. Here's another example of nonlinear. And this one, I believe, if I remember correctly. Oh, no, this is just a quadratic in line. So that's a pretty easy one. But this one down here is another quadratic in line. So 2 more examples. Here's what I would do is I would write this down on paper and work it. However you want to do it. Substitution or elimination, I don't care, because they give you the steps of both. And then check it right here. There's the 4 steps they did. There's the 5 steps they did for elimination. Work that and see if you get the same answer they've got. Since they give you the answers, this is a great chance for you to see if you understand how to solve this on your own. Before it counts, right? Before you're getting a grade for it. Good chance right there. Let's look at the next page. All right. Oh, yeah, this one got a little fun yesterday. Now, how about a rational equation? You're like, what? That means there's an x in the denominator of a fraction. No way, Mr. Brock. Yes, absolutely. Here's 2 examples right here. They're almost the same. It has a rational equation and then just a linear equation. And this one has a rational equation and a linear equation as well. So let's just take this first one here. Okay. Well, that looks interesting. I better sharpen the pencil on this one. You're thinking, okay, this has got to be a lot harder, right? Because it's got a fraction. But we know how to get rid of fractions pretty easy. So let's go ahead and start working this. Let's substitute again because we got y equals right here. So let's just substitute in there. So x minus 1 equals x plus 1 divided by x minus 1. So we use substitution. We substituted this in right there. Substituted. Now, the first thing I want to do is I want to get rid of this fraction, right? It's like, oh, man, it's a fraction. That's ugly. I don't want a fraction. Well, let's just think about it. If we have a fraction, let's say we have 2x equals 5/7. And we don't want to work with a fraction. It's like, oh, I don't want to work with a fraction. The way you get rid of a fraction is you multiply by the denominator, whatever's on bottom. So this, I'd multiply it by 7. Multiply 7 times 5/7, it's just 5 because they cancel each other out. There's a 7 on top, there's a 7 on bottom, and they cancel each other out. Over here, 2x times 7 is 14x. So x equals 5/14, right? Because we divide both sides by 14. Now, the answer ended up a fraction, but it was easy to work when I get rid of it. So up here, I just want to get rid of the fraction. So I do that by multiplying both sides by what's on the bottom, x minus 1. So now this cancels out. you're dividing by x minus 1 and you're multiplying by x minus 1. And if you divide something and multiply by the same number, that's just cancel each other out. So this is equals x plus 1. Now on this side, we've got x minus 1 times x minus 1. So we have to distribute x times x squared, x times negative 1, negative x. Now distribute the negative 1. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. So here's what I've got. I've got x squared minus x plus 1 equals x plus 1. Simplify. Those are like terms. So I've got x squared minus 2x's plus 1 equals x plus 1. I need to move everything over. I have a quadratic equation. Negative x and negative 1, negative x and negative 1. I could have moved those separately. I'm just putting them at the same time. I can subtract x to both sides and then subtract 1 to both sides. I'm just kind of making it a little easier to deal with. And look, that went away. Plus 1 minus 1 cancels out. X minus x cancels out. Plus 1 minus x squared minus 3x equals 0. All right, let's check our discriminant to see what we need to do. So b squared minus 4ac. B squared. B is the x term. So it's negative 3 minus 4 times a. A is 1. And there is no c. C is 0. So all of this is going to be 9 minus 4 times 1 is 4 times 0 is 0. So the discriminant equals 9, which is a perfect square. It's a positive perfect square because that's 3 times 3, right? So that tells me there's going to be 2 nice answers. So I should continue. I know there's solutions, and they're actually going to be nice solutions. As long as this isn't negative, we need to continue. If this is negative, then there's no solutions. So to solve this, first thing we do is we see a greatest common factor. See, both of those terms have an x, so let's factor that out. X out of x squared leaves 1x. X out of negative 3x leaves a negative 3. So that means x equals 0 and x minus 3 equals 0, which means x equals 3. So the 2 answers are x equals 0, something y, and 3, something y. Well, let's find out what it was. We can choose either one again. For the first one, I'll do the bottom one. Y equals 0 minus 1. So y equals negative 1. Okay, so when the x is 0, the y is negative 1. Just for fun, I'm going to choose the other one. I can do this one. We know it's going to be 2, right? Because it's 3 minus 1. But let's just see what it ends up with the top one, just for fun. Equals 3 plus 1 divided by 3 minus 1. Substituting in for x. So 3 plus 1 is 4. 3 minus 1 is 2. 4 over 2, it is 2. So this is our 2 solutions. All right, let's graph this crazy radical solution. This irrational, the rational equation. It's not irrational, it's a rational equation. So I have to put that in parentheses to keep it all on top of the fraction. Oh, not plus 1. And then divided by x minus 1. So I put those in parentheses so it does it correctly. Look, there's what a rational equation graphs like. All right, it's got 2 asymptotes. There's an asymptote at positive 1 on the x-axis and the y-axis. 2 different asymptotes. The other equation that we compared it with was y equals x minus 1. Okay, there's the 2 solutions we found. 0, negative 1, 3, 2. 0, negative 1, 3, 2. So again, we've done rational equations, we've done quadratic equations, we've done linear equations, any combination of them. We can do them elimination or substitution. It's just a little different math. It's all working out pretty nicely. Let's see, they have another one down here. This one's a little different. Y squared plus x squared equals 20. Solve it by elimination or substitution. Any idea what that's going to graph? X squared plus y squared equals 20. You recognize what kind of equation that is? I'll put it on here just so you can see it. But y squared plus x squared equals, yeah, it's a circle. When you got x squared plus y squared, that's a circle. And the other equation, I think, was negative 2x equals negative 2x. Yeah. Yeah. So whether you're working by elimination or substitution, you should get two answers because the line cuts through the circle once. Now, it is possible to have a circle and a line have one solution. One solution. You're like, how is it going to cut through the circle and not come back out? Here it is. Right there. It could just touch the edge of the circle, and that's the only place those two graphs meet. Right there at 4, 2. Negative 4, negative 2, sorry. See, that's the only, so there couldn't, even though you have a circle, it's easy to have two solutions and zero solutions, but you can have one solution with a circle. And of course, if you have a parabola, man, there's lots of potential there. Let's see, x squared. How about that? There's two solutions. How we make this 4x squared and put a minus 8 on it. Now look, there's four solutions with a parabola and a circle. So you can have a lot of solutions depending on what shapes you're working with. Of course, you can have infinitely many solutions if they're the exact same graph, right? So don't forget, anything's possible depending on what shapes you got. Here's our lesson summary. Solving systems of nonlinear equations. So again, substitution and elimination works just like it did with linear. You just got a little different math to do when you have a quadratic equation, right? You got to factor it or, use the quadratic formula, something on there with the quadratics. But otherwise, it's still going to be the 2 points or the 0 points or the 1 point they have in common. So there is a whole page of practice problems for you to see if you know what you're doing. Solve each of these on your own paper. Make sure you know how to do substitution, elimination, and graphing. Now, that being said, I'll never ask you to do all three. Solve this, show me how to do this by substitution, elimination, and graphing. No, generally you pick your favorite. Hey, I love this substitution. That's real easy. I'm just going to use substitution. Great. Most of the time, sometimes it may be a really nasty problem by substitution. It might be easier to eliminate sometimes. That's why it's good to know that. But generally, all three of them will get you the same answers. So, look, there's 10 problems here too. 10. So once you get this first one, and it shows you how to do it either way. So however you try it, you can look and see what they did. Then there's another problem, and another problem, and another problem. Do you need to do all 10? Probably not, because let's see. This one, let's look at the first few. This is a quadratic and linear. So we have a line and a quadratic equation. The next one, line, quadratic equation. Line, quadratic equation. Line, see there's 4. The first 4 are all lines and quadratic. If you do the first 1 or 2 and you're not having any problems, like, okay, I understand lines and quadratic and parabolas, I can do that, then you probably don't need to do all 4 of them. If you're struggling and starting to get wrong answers, maybe you should do the others for more practice. Then we have, here's another line in quadratic. There's 5 quadratic equations and lines. 6, 7. Okay, so there's 7 problems that are all a line and a quadratic equation. Some of them probably have no solution. Some of them probably have rational or irrational solutions. Use that discriminant when you can to check. This one has 2 quadratic equations. Okay, maybe you should try that one. This one has 2 quadratic equations. And this one, so there's 3 that have 2 quadratic equations. So if you do the first one or two and you don't have any problems, you feel comfortable, okay, don't do all three. Now look, here's activity 2 on the same page. Oh, here's a rational equation with a line. See how many's down here? 3. There's only 3 problems. The second one, a rational equation with a line. And the last one, a circle and a line. Okay, so there you go. There's 13 practice problems for you to practice till you get comfortable. Let's look at, there's the assignment for this. Well, the solutions. Here's a line and a quadratic equation. What's the solution? Here's 2 quadratic equations. Oh, here's the graph. Which of these equations is this a graph of? One's a line and the other one's a rational equation. Easiest way to answer that is go put these in. Now you can eliminate 2 of them right off the bat. Just look at the linear equation because it has y equals x plus 4 and y equals x minus 4. Y equals x plus 4, y equals x minus 4. So you should be able to look at the line and say, oh, well, I know it's not that one because it's either x plus 4 or x minus 4. You should be able to look at the y-intercept and go, oh, it can't be that one. So that eliminates 2 answers for you already. But you can always, once you get it down to 2, put them in Desmos and see which one looks like this. See which one doesn't look like that. Number 4, what's the solution to the following system's equation? This is a circle and a line. Circle and line. And here we have a line and a parabola. It wants to know which one of these systems is being graphed right here. Looks like there's 2 solutions. So which of these have those 2 solutions? All right. So 1.03, not very tricky. As long as you practice enough, it shouldn't be hard. But look at this. The first thing we see is for the assignment on page 6, choose option 1, work alone. This is not multiple choice assignment. All right. The city of Phoenix, Arizona has laid out its main streets in a linear grid. Roads run north and south and east and west. So if you want to find the intersection of streets, it's pretty easy because every road is a straight line. All right. Compare that with Bella Vista, which the map of Bella Vista looks like a brain. There's not a straight line in the whole town. It says, imagine if Phoenix used only curved roads or circular roads or roads that been off in different directions, like Bella Vista. If we think of linear roads and nonlinear equations, we can now use graphs to solve the systems that have nonlinear equations. So these graphs can be your GPS to find the intersection of the roads. So looking at page 2. Okay, we have a video where she's going to show us graphing, how to solve by graphing. Now, the nice thing is we just spent the entire first lesson graphing them. So we're already familiar with solving by graphing because we've been doing that to check ourselves all through the substitution and elimination. But she's going to show you, and her graphs, she's just sketching a graph. So hers actually would not give you an exact answer. I would not do it the way she does it. I'm going to show it to you anyway, just because it kind of entertains me. But if I was saying what's the solution to these 2, you would have to have Desmos so you have an accurate graph. You'll see when she does this. If you need an accurate answer, you'll see that hers is not accurate, and you'll figure that out real quick. You'll go, oh, that wouldn't give me the answer. You're right, it would not. But let's take a look.
Hello, today we're going to look at graphing nonlinear systems. So we have some functions up here that we're going to graph on our coordinate plane. And just remember that when we're graphing a nonlinear system with a linear system, they're always going to intersect at least one point. So let's take a look at our first one. We have f of x is equal to 3 over x minus 2. This tells me that I'm going to have an asymptote at 2. So I'm going to go over here and draw my vertical asymptote at 2. I also know that it has a horizontal asymptote over the axis. And then I can go ahead and draw my graph. My second graph is a line. I have 1/2 x plus 2. So I'm going to go ahead and go to my y-intercept at 2. And then the slope is going to be up 1 and over 2. So it looks like we have 2 intersections. There's one right here, and there's another one over here. Now make sure that you don't think that's an intersection because that's actually our asymptote. The intersection is right over here with the two graphs. So let's take a look at our next one. This is f of x is equal to x cubed plus 2x squared minus 3x plus 2. So because it is a cubic function, we know that the end behavior is going to go down on the left and up on the right. And I also know that the y-intercept is going to be at 2. So I'm going to go up here, and I'm going to just draw a sketch. Remember that if you want an accurate sketch, you can use any graphing technology or you can plot points. My next one is also going to be a rational expression, 1 over x plus 2, which means that I'm going to go ahead and shift it 2 spaces up. So I'm going to draw my asymptote. And this one has a couple more intersections. You'll notice we have an intersection here, and we have an intersection here. Now, the only exception to this rule is if you did have a hole in one of your graphs, then maybe there would be an area where they didn't intersect. And that's how we graph nonlinear systems.
All right, so her method is good for showing you how many solutions, but not identifying what the solution is. Because we don't know how accurate, especially that up and down one, the x to the third, we don't know how accurate that is at all. So I wouldn't rely on that to do that, but it does give you a good idea that, hey, okay, there should be 2 solutions for this. Okay, I'm not going to spend a whole lot of time graphing these because we've been doing that all along and we know what it looked like. Let's pick a couple. Let's do example 2 here. Y squared plus x squared equals 16. Okay, 16. I just changed the size of the circle. And y equals negative x plus 4. Negative x plus 4. Okay, there it is, a circle and a line. This one has 2 solutions, one on the y-axis, one on the x-axis, interestingly enough. So it's a circle with center to origin, and there they graph it. So graphing, a lot simpler. Here's a good problem to talk about. Because what happens when I graph? I'm just going to copy this and graph it. We got negative x squared plus x minus 3 equals negative x minus 3. I'm just going to graph that. Okay. Get rid of these equations. There it is. Oh, that's negative x2. Let me make sure it's squared. Negative x squared plus x minus 3 equals negative x minus 3. Look at the graph. It's just 2 straight up and down red lines. Well, that's not right. We know this is linear, and we know this is a parabola. That's not a parabola and a line. What's the problem here? The problem is we need to set this up like a systems of equation. That's just one equation. I should take one of these equations and put it on a different line. Look, now if I just leave the first one, it is a parabola. Here's the second one. I'll take off that equals. There's the line. So I have to take the first equation and put it on one line and the second equation on a different line. And now it graphs a parabola and a line, and I can see the solutions at 0, negative 3, and 2, negative 5. So that's a key point that you need to understand looking at a problem like that where it's all just one equation. Okay, and we kind of got the idea when we were doing this because we made it all one equation when we substituted right there. X squared minus 9x plus 18 equals x squared plus 2x. But it started out as 2 different equations. So if we get one like this, we need to turn it into this. Separate those when you graph them so that it looks correct. You know what you're doing. So here's some of those where they give you the practice. They give you 2 equations on the same line, one on each side of the equal sign. You just have to separate those. Oh, let's look at this one. Absolute value. So let's do the first one, negative 1/4 x plus 4. So here's one of the equations. I'm going to change it to a 1/4. Negative 1/4 x plus 4. Okay, there's the graph of negative 1/4 x plus 4. And the other one was the absolute value of x plus 2 minus 3. Now for Desmos, I got to go down here and choose their absolute value button. Absolute value, and it was x plus 2. So in the absolute value, I'm putting x plus 2. And then at the end, I'm putting minus 3. Minus 3. Okay, so there is the absolute value graph with a line, 2 solutions. One is at negative 12.7, the other one's at 4.3. Nice solutions. Didn't have to have fractions or decimals or anything. So, all right, so pay attention to that. If you have them all in one line, to make sure you're graphing 2 separate lines or shapes. All right, page 4. Applications. So this is putting it like a word problem. Okay. So like it says, the height of a falling leaf is modeled by this equation. H equals negative 4.9 t squared plus 30, where H is the height and T is the time. A remote control helicopter is trying to catch the leaf in an amazing display of piloting. The helicopter's height has this, H equal 2T. When will the helicopter catch the leaf? Can you graph these? You're like, wait a minute, I've got H's and T's. What happened if I put that into Desmos? That's a T squared. So anyway, it'll take H's and T's. Look at there. It's happy with that. You can change them to X's and Y's if you want. And then H, the other one is H equals 2T. So let's put that equation in there. There it is. And it says, when will the helicopter catch the leaf? At 2.278 seconds. And this will be the height that the leaf is at, 4.55. So it says, look at the possible solutions. Now there's another solution over here. But think about this. This is a real life situation where we have a leaf falling and a helicopter, remote control helicopter trying to catch it. This is negative numbers. We have to throw that out. There's not 2 solutions. We throw it out because there's no way the helicopter is going to catch it in negative 2.68 seconds. We can't go back in time. And this is 5 feet underground. They're not going to be 5 feet underground. So we have to throw out solutions if they don't make sense in a real life situation. 2.27868 is a valid solution. So check your thoughts. They show the same graph. The solution of this is unreasonable, which means this is the right answer. Here's another example given t-shirts. So see if you can set up your system. Oh, here's some different function you might be using with nonlinear. So you have linear, you have a constant function, quadratics, cubics, radicals that use a square root in the function, absolute value, or rational. So it could be any of those. All right, here's the last thing I want to look, because this is very, very important for the assignment that we're about to do. You have an assignment that says at the top of the page, for the assignment on page 6, you'll be choosing option 1, work alone. We're going to look at that. Here's the lesson summary, by the way. But we need to talk about this graph right here on the screen. This is what you call a piecewise graph. Piecewise graph of a function. Now click this and we can look at the different pieces. There's graph piece 1. See, it uses this flat line of -1 when x is less than 0. Piece 2 is a totally different graph. It's the graph of x minus 1 when x is greater than 0. When you put them together, they look like that. It's a piecewise graph. So let's talk about a little bit on how you would create a piecewise graph. And let's see, I got some graphing paper down here. There we go. So let's say I want to create a piecewise graph. So you write it a little differently, because let's just do 2 pieces. We can do as many pieces as we want, but we need at least 2. So what does f of x equal? Well, let's see. I'm going to say when x is less than 2, so anytime this side of the graph, I'm going to use x squared. And that's only when x is less than or equal to 2. Okay, so let me graph x squared. Graphing x squared when it's negative 2. So this is the xy table. It's 4 because negative 2 squared. Negative 1 squared is 1, 0, 0. 1 is 1, 2 is 4. So if I'm graphing that, here, I'll do it in blue here. 0, 0, negative 1, negative 2, 4, 1, and right there. So I need to connect these, and this is going to continue. Now, why didn't I continue this one? Because I said I only want to use this equation when x is less than or equal to 2. When it's equal to 2. Over here, x is bigger than that, so it doesn't count. I want to use a different equation over here. I want to use f of x equals, let's say, negative x plus 2. Negative x plus 2. And that's any time that x is greater than 2. So I need to graph that line. That's a line. It has a negative 1 slope. And it has a y-intercept of plus 2. So it would be a y-intercept up here and a negative 1 slope. Here, I'll get my ruler to make it nice and neat. Negative 1. But it doesn't start. It didn't start until here. It didn't start here because I only graph it when it's greater than 2. Now, here's a problem. What about when x equals 2? What about when x is actually 2? Because this is when x is 1, this is when x is 2, this is when x is 3. Which graph do I use? This says greater than 2. This is less than or equal. So actually, this would have a circle, a hollow circle right there. Because when x is 2, it doesn't count. Right here, you have to use that one. Now, I could, if I wanted to, I could change this. And let's say, all right, instead of doing that, there's what I want. Instead of doing that, I'm going to say f of x equals, this one I'm going to leave, x squared, anytime x is less than or equal to 2. But this one I'm going to change to negative x plus 5. When x is greater than 2. So I just changed, the only thing I changed instead of plus 2, it's plus 5, which is going to raise this graph up 3. Right, it's going to raise this graph up 3. If I raise it up 3, now it connects right there. I don't have to worry about a hollow circle. And when I graph it now, all right, see the difference? The blue one and this pencil one is this piecewise function right there. If I switch to the red one, ignore this one. This is the graph of that one. I need to raise this up a little bit, show a bit more of the page. This is the graph of the red one. Now you see why this is called a piecewise function? Because I took a piece of this function, x squared. I just took a piece of it because this is the graph. The blue is the graph of x squared. But I just took a piece. I stopped when x got to 2. When x is bigger than 2, I took a piece of this linear equation. And I put those two pieces together to make a function. Your function can touch or your function doesn't have to touch. But if it doesn't touch, one of them has to be a hollow circle. Because it's not a function. If not a function, if the graph includes the point 2, 3 and 2, 0. If both of those are true, this is no longer a function because the x has 2 y's. So that's why this one has to be a hollow circle and that one can be a filled in circle. So it fits one or the other. So knowing that, let's go look at our assignment. There is some practice problems here for more graphing, solved by graphing. Check your work, gives you some more to check. Gives you the graph if you need 6 problems there. But let's go look at the assignment. The assignment is in the lesson. Here, let me go show you that for sure too. So if I go to the assignment, there's nothing there. The assignment's on page 6, the work alone. Submit your assignment based on the instructions. Look, I can submit a file. If I want to attach a file or a Google file, I can attach a file. I can do my work on paper, take a picture of it if I want to. I can do it on Google Doc and just attach it, attach a file. Or I can type it all up in here and put pictures or whatever I need to do. I can insert images if I have a picture of a graph or something. I can do it all here, or I can attach a file. However you want to do it, submit your work. But let's go to page 6 and see what the assignment is then. So let's go back to the lesson. Let's go to page 6. Go down to work alone. See, this says choose work alone, option 1. After a dreary day of rain, the sun peeks through the clouds in a rainbow form. Here's a graph of the rainbow. You notice it is a parabola. And here's the equation for that parabola. Negative x squared plus 36. If you want to put that in Desmos, you can do that and say it's negative x squared plus 36. If you want to play with it in Desmos, you can put it in Desmos. Now it says, here's 3 parts to the assignment. All right, 1, 2, and 3. You need to answer 1, 2, and 3. Number 1, in the distance, an airplane is taking off. As it ascends during takeoff, it's going to make a straight line, slanted line, not a straight up and down line, a slanted line that will cut through the rainbow at 2 points. Well, that makes sense, right? If you got a rainbow, airplane's going to go right through the rainbow, 2 places. Boom, boom. Whichever way you want it to go. It can be upward this way or upward that way, whichever. Create a table. Okay, here's number 1. Create a table of at least 4 values for the function, for your airplane function, for the airplane. That includes the 2 points where it crosses through that graph. So when you make a table, you have to include the 2 points where it intersects, which would be the solution, right? You have to include those 2 points. All right, number 2, analyze the 2 functions. One function is the rainbow. The other function is the line that you create for your airplane. And answer these questions. What is the domain and range of this rainbow? You can look at it on the screen. What's the domain and range? Obviously, it doesn't go any higher than 36. Looks like it goes to infinity. Domain and range. What does that represent? What does that 36 represent? What is the domain being negative infinity to infinity? Do all these values make sense in this situation? It says the rainbow goes from 36 down to negative infinity. Does the rainbow go to negative infinity? Why or why not? What are the x and y intercepts? Okay, here's x intercepts. There's a y intercept. What do those represent for the rainbow? Now, is the linear function that you made for your airplane, is that a positive or a negative? And it could be either one. Depends on the function you make. I don't know if your airplane's taken off from the left or taken off from the right. So it's going to be positive or negative depending on how you build it. And what are the solutions to the system of equations? Because you have a system of equations. You have a parabola and a straight line. What's the solution? What's it represent? Okay, and then here's number 3, which is totally unrelated. Okay, get this. Number 3 is totally unrelated to number 1 and 2. Totally. Create your own piecewise function with at least 2 functions. Create your own piecewise function using at least 2. You can make more functions if you want. And then show the steps for graphing it. And then graph it. Graph the function by hand or using the graph software. Remember to submit the graph. So that's totally unrelated to the airplane and rainbow. Number 3 is totally different. Create a piecewise function, which we just did right here, right? This was a piecewise function, and this was the accompanying graph that went with it. So I graph x squared when x is less than or equal to 2. I graph negative x plus 5 when x is greater than 2. That's the explanation on how to graph it. And that is the assignment right there. So I wanted to make sure you knew exactly what to do. All right, let me remind you it's an 8-day Friday. Maybe you should start on this assignment. Because if you have trouble, you can come in Friday and say, okay, Mr. Brock, I'm kind of lost. I got my airplane built, but now I'm on those questions and I'm not understanding. Come see me. I'll be here. If your grade's under 70%, probably means you're behind on some work and not turning things in. So that'd be a good idea to get some things turned in as well. But, all right, don't get behind, guys. We're going to wrap this up pretty quickly and move on. So I will let you go. Have a great week. If I don't see you Friday, I'll see you next week.